Hi students, today we talked about special triangles, and the first triangle that we talked about was triangles that are 45, 45, 90. So already we know it's a 90 degree, it has a 90 degree angle, so it is a right triangle, so it's a special kind of right triangle. And so this special right triangle, in this case, looks something like this, where this is my 90 degree angle, and these two angles are congruent to each other. Therefore, they must be equal to 45 degrees. So we learned about a relationship here. We learned today, and yesterday, that we can use the Pythagorean theorem, and the Pythagorean theorem says a squared plus b squared is equal to c squared. And so that's a given. And then we also can apply our base angle theorem to this same triangle. And the base angle theorem states if I have two angles of a triangle that are congruent, the sides opposite these angles are also congruent. So in this case, A is equal to B and B is equal to A. So I'm going to just put it in terms, so this side is A and this side is also A. So in this case, I have a squared plus b squared, a squared plus a squared, because I'm going to substitute a in there, is equal to c squared. So if I combine my like terms, I have 2a squared is equal to c squared, and I want to solve for c in terms of a. And so to do this, I have c squared, and I want it to actually equal just plain c. So to undo squaring c, I'm going to take the square root of c. And so if I take the square root of one side, I also have to take the square root of the other side. So that's going to leave me with c on the right side of my equation. And here, in this case, this actually is 2 times a. So I have a pair of a's, so I'm going to bring my a out because a squared is a. But I'm left with radical 2. So in this case, c is actually going to be equal to a times radical 2. Or we can also substitute in, a lot of times we use x as our variable. So if I know that one side of a 45, 45, 90 degree triangle is x, then I know the other side is x. And then if I know that, then I know that my hypotenuse is x times the square root of 2. So today in class we learned, okay, if I know that x is going to be equal to 10, that's a given. I can plug in x, and so then I know my hypotenuse, in this case, is going to be just 10 times the square root of 2, and that's my answer for my hypotenuse. Again, if I know that my hypotenuse is 999, my side or one of my legs is 999, I know that the other leg's 999. And then I know that my hypotenuse is going to be 999 times the square root of 2. 9 radical 2. Oh, 999, pardon me, 999 radical 2. So that kind of helps you get into that situation. But every now and then we're going to be given the hypotenuse. So if I'm given the hypotenuse, and I'm just going to substitute in c, so whenever I'm talking about the hypotenuse, I'm going to say c is equal to 10. And I know that c is equal to x times square root of 2 from my figure up here, and we just proved that. So I'm going to set 10 equal to x root 2. So solving for x, because that's going to be the leg of my 45, 45, 90 degree triangle, I'm just going to divide by radical 2 and divide by root 2. And at this point, I'm to the point of saying, okay, 10 divided by radical 2. But I know that I can't have a square root in the denominator, so I have to multiply the denominator and the numerator both by radical 2. And it becomes 10 rad 2 divided by the square root of 4. And I can continue to simplify this to say 10 rad 2 to square root of 4, which is 2. And then from there, simplify and say x is going to equal 5 radical 2. So that would be what x is equal to. Let's do another one, another example. Let's do an example that has maybe my c is equal to 7. So in this case, again, I'm going to set x radical 2 is equal to 7. I'm going to solve for x by dividing both sides by square root of 2. And I'm left with x is equal to 7 square root of 2. And I can't have a square root in the denominator, so it becomes x is equal to 7 radical 2 divided by radical 4. And then I can simplify from there and say 7 radical 2 divided by 2. And in this case, it doesn't come out to be a whole number, so I can leave it in this form and say 7 radical 2 divided by 2. And that would be my final answer. Okay, the next situation that we have is a special right triangle, and that is a 30, 60, 90 degree right triangle. And this looks something like this, where I have a right angle, I have a short side, and that's going to, small angle, and that's going to be opposite my short side, short leg, excuse me. And then this angle here is going to be 60 degrees, and that's opposite my long leg. And then again, the side opposite the right angle is the hypotenuse. So there's a rule here, and we learned about this today. And the rule here states that, and this is not drawn to scale obviously, because this looks like a 45, 45, 45, is if I know my short leg, so if my short leg is x, my hypotenuse is going to be 2 times x, and then my long leg, which is opposite 60 degrees, is going to be x times radical 3. So the same situation occurs that occurred up with the 45, 45, 45. And the easiest one to know is if I know my short leg, or my x, is going to be equal to 10, then I know my c, or my hypotenuse, is going to equal 20. And I know my long leg is going to equal, and my long leg is always opposite 60 degrees, 10 radical 3. So just follow the same formula. Now, when we don't know, we know the hypotenuse, so we know the hypotenuse, or c, is equal to, let's say, 18. I know my short leg is going to be equal to 18 divided by 2, or 9. Because x is going to equal 18, or 18 is going to equal 2x, basically, because 2x is equal to 18. So I divide both sides by 2, and x is going to equal 9. And then my long leg, which is my x radical 3, is going to equal 9 radical 3. Next thing, sorry, I didn't have that showing, pardon me. The next thing is sometimes I can be given my long leg. So my long leg, or x radical 3, is going to equal, let's say, 15. So this is my 15 is my long leg. So I want to solve for my short leg, which is x. So I divide by radical 3. And then when I do that, I can't have a radical in the denominator. So it becomes x is equal to 15 radical 3 divided by 3, because the square root of 9 is 3. And then I can simplify from here, and it becomes 5 radical 3, because I can simplify and say 15 divided by 3 is 5. So that's kind of how you solve that. Once I have what x is equal to, then I can say, okay, well, my hypotenuse is going to equal 2 times whatever my short side is equal to. So my hypotenuse is going to equal 10 radical 3. So again, I know that my hypotenuse is equal to 2 times my short side, and so that would be 2 times 5 is 10, and then I'm still left with radical 3. So hopefully this will help get you started and help you understand about our special right triangles.